planet covered in a global ocean of molten rock is somehow holding on to an atmosphere. It circles its star in 10.5 hours. One side never sees night. It is scorching hot, ancient beyond measure, and according to everything we know about planetary physics, its air should have been stripped away billions of years ago. Webb just proved it wasn't. You're listening to Stardrift FM. Tonight, a lava world that defied extinction. Webb finds an atmosphere no one thought possible. A comet dissolves in real time, and Hubble accidentally catches every second of it. A German rocket takes its second shot at making history from European soil. Our nearest galactic neighbor turns out to have survived a catastrophic collision. Hubble compares 25 years of watching a dead star expand, and 2 planets caught being born right now around a star younger than the dinosaurs. Grab your coffee, let's get into it. Here's what you need to know about TOI 561b. It orbits its star 40 times closer than Mercury orbits our Sun. 1 year there lasts 10.5 hours. The surface is not rock, it's a global ocean of liquid magma running thousands of degrees hot. And its star is ancient, about 10 billion years old. Our own Sun is 4.5 billion. This planet has been sitting in that furnace for longer than Earth has existed. Every model we had said, a planet this hot, this old, with this much radiation hitting it, it loses its atmosphere. Stripped clean by stellar winds. End of story. A team from Carnegie Science pointed Webb's NIRSpec instrument at it for 37 straight hours, watching the planet complete nearly 4 full orbits. They were measuring the brightness on the day side versus the night side, trying to understand the heat flow. And the dayside temperature came back cooler than expected. Not by a little, by about 400 degrees. On a world where the dayside should hit 2,200 degrees Celsius, they measured 1,800. That gap is enormous. And there is only one explanation. Something is redistributing heat from the day side to the night side. Something is wrapping around the planet, an atmosphere. Lead researcher Joanna Teskey describes it as a wet lava ball. Gases bubble out of the magma ocean, feed the atmosphere, and then the atmosphere gets sucked back into the molten surface. A cycle, a balance. The planet must be holding on to far more volatile material than Earth ever had, just to keep this going for billions of years. This matters because we've been assuming ancient ultra-hot worlds are barren. They're not. The chemistry that makes life possible, volatiles, outgassing, atmospheric cycling, can survive in environments we've never taken seriously as candidates. TOI 561b itself is not going to support life, but the idea that it can hold an atmosphere at all changes where we look next. 10.56 hours. That's how long a year lasts on the lava world. By the time you finish this episode, it will have orbited its star twice. Hubble wasn't supposed to be watching this comet. Researchers had pointed the telescope at C2025K1 Atlas for an unrelated science program. They wanted to study its chemistry. 3 20-second exposures, 3 consecutive days in November. When the data came back, the team realized what they actually had was something nobody had ever caught before. The comet was in the middle of falling apart. Hubble resolved at least 5 fragments, each piece wrapped in its own fuzzy cloud of gas and dust, its own coma. From the ground, those fragments barely showed up as blurred blobs. Hubble could see them cleanly. And during the 3 days of observation, one of the smaller fragments also broke apart, producing a second-generation piece. The team estimates the comet had started breaking up about 8 days before Hubble caught it. The timing was pure luck. Here's the physics. The previous month, K1 had swung through perihelion, its closest approach to the Sun, passing inside Mercury's orbit, where the heating and tidal stress are extreme. Ices vaporize. Pressure builds inside the nucleus. The rock cracks along internal fault lines, and then the pieces drift apart. What makes this comet stranger is its chemistry. Ground-based spectroscopy picked up something unusual. K1 is heavily depleted in carbon chain molecules. Most comets left over from the early solar system have a certain balance of carbon compounds. K1 doesn't. Something about its origin was different. Past famous comet breakups, Shoemaker-Levy 9, which shattered before crashing into Jupiter, or Ison in 2013, were usually captured after the fact, or only partially. K1 is the earliest stage of fragmentation that Hubble has ever documented. It's a rare window into what the inside of a comet actually looks like, and how these ancient time capsules from the beginning of the solar system eventually come apart. For 70-plus years of the space age, no rocket has ever reached orbit from European soil. The European Space Agency launches from Kourou in French Guiana, technically France, but in South America. Everything else, Soyuz, Ariane, Vega, same place, never from the continent itself. Tonight that changes, or at least an attempt is being made. Isar Aerospace is a startup from Munich, Germany, founded in 2018. Their rocket Spectrum is a two-stage small launcher. 28 meters tall, 10 engines on the first stage, burning liquid oxygen and propane, designed to lift up to 1,000 kilograms to low Earth orbit. Their goal is to give European satellite companies sovereign access to space. No waiting for an Ariane slot. No depending on American or Russian rockets. The first Spectrum launch was March 30th, 2025. It failed 30 seconds into flight. Vent valve opened unexpectedly, the rocket lost attitude control, and it fell into the sea off Norway. Isar rebuilt, investigated, and planned the second attempt for January. That date slipped when a pressurization valve issue showed up during testing. Now it's March 25th, 2026 tonight. Mission name, Onward and Upward. This flight carries 6 real customer payloads, 5 commercial CubeSats, and a technology demonstration experiment. The stakes are clear. If Spectrum clears the pad and reaches orbit tonight, it's the first time in the history of spaceflight. If it doesn't, Isar will rebuild again. The European space sector is watching. If you're ever in the southern hemisphere on a clear night, you can see this small Magellanic Cloud with your naked eye. It looks like a detached piece of the Milky Way, a faint smear of light in the sky. It's one of our nearest galactic neighbors, a dwarf galaxy about 200,000 light-years away. For decades, astronomers have found it deeply confusing. Normal galaxies rotate. The stars orbit the galactic center in an organized way, like cars on a racetrack. The SMC doesn't do that. Its stars move in random, chaotic directions. Its gas doesn't rotate properly. And when you measure the SMC's depth, how deep it is along our line of sight, it's much larger than you'd expect for a galaxy its size. Something clearly happened to it, but what? New research from the University of Arizona has the answer. Hydrodynamic simulations, combined with observational data from Gaia and other surveys, show that about 100 million years ago, the small Magellanic Cloud crashed directly through the disk of the large Magellanic Cloud. Not a glancing blow, a direct impact. One galaxy punching through the other. The LMC is about 10 times more massive. When the SMC hit, the gravitational disruption threw the SMC stars into random motion. The LMC's dense gas applied pressure on the SMC's own gas, effectively destroying its rotation. And the tidal forces stretched and elongated the galaxy, creating that unexplained depth along our line of sight. And here's the uncomfortable implication. Scientists have used a small Magellanic Cloud as a standard example, a benchmark for understanding how smaller, irregular galaxies form and evolve throughout the universe. If the SMC is a shattered wreck still recovering from a collision, it's not a clean example of anything. Every paper that used it as a reference galaxy may need to be revisited. In the year 1054, Chinese astronomers recorded a new star in the sky. It was bright enough to see in broad daylight. It stayed visible for 23 days before fading. That explosion, a supernova, left behind what we now call the Crab Nebula, a cloud of expanding gas and dust powered by a neutron star at its center spinning 30 times per second. Hubble first point had added in 1999. Now, 25 years later, a team has compared the 1999 observation with a brand new 2024 image, using a more advanced camera with a wider spectral range. The result is something rarely possible in astronomy. You can see a celestial object change during a human lifetime. The filaments, those glowing threads of gas radiating outward from the center, have visibly moved. The expansion rate works out to about 5.5 million kilometers per hour. Peripheral filaments move more than central ones. And rather than stretching apart, they appear to have moved outward as intact structures, like ribbons in the wind. There are new structural details too. Some bright filaments appear to cast no shadow on the glowing interior, which means they must be on the far side of the nebula, with the glow between us and them. The new camera also reveals changes in temperature, density, and chemical composition across the cloud. The Crab Nebula will not stay the same. By the year 3000, it will cover an area of sky roughly 20 times larger than it does today. The neutron star will keep spinning, keep injecting energy, keep pushing those filaments outward. And astronomers who point Hubble at it in 2050 will have 50 years of data to compare against 1999. This is what long baseline astronomy looks like, not a single photograph, a time-lapse of the universe. Our sun has been burning for 4.5 billion years. By the time the first multicellular life appeared on Earth, about 600 million years ago, the sun had already been alive for 4 billion years. The planets of our solar system formed roughly 4.5 billion years ago, and there is no record of what that looked like. WISPIT 2 is 5.5 million years old. Astronomers observing this infant star, 437 light-years away, have confirmed 2 planets still in the process of forming. You can see them in the image, 2 gas giants, labeled WISPIT 2 and WISPIT 2c, sitting in gaps they've carved out of the disk of gas and dust surrounding the star. The disk still glows. The planets are still accreting material. A third gap farther out suggests a third planet may be forming at Saturn's scale. The data was published by a team at the University of Galway, led by PhD student Chloe Lawler, using ESO's Very Large Telescope, and confirmed with ALMA high-resolution imaging. This is only the second confirmed case of a 2-planet protostellar system being directly observed. The first was PDS-70, discovered in 2018, where 2 forming gas giants were caught carving their paths. WISPIT 2 now joins that very short list. The arrangement of the 2 planets, a larger outer gas giant and a more massive inner one, echoes what we think our solar system looked like when Jupiter and Saturn were still growing 4.5 billion years ago. We are, in other words, watching a replay, just 400 light-years away. Tonight on Stardrift FM, a lava world beating the odds with an impossible atmosphere. Hubble stumbling upon a comet's final moments. Europe making its play for sovereign orbital access from Norwegian soil. The small Magellanic Cloud finally confessing to a 100-million-year-old crash. 25 years of a dead star expanding, frame by frame. And 2 planets caught mid-birth in a solar system that's still righting itself. This is Stardrift FM. Thanks for tuning in.